Hello everyone, welcome back to my channel. In this video, we are going to talk about data types. And this will give you a basic understanding of why Java is considered as one of the strongly typed language. I know you will enjoy this. So, a variable in Java can only hold one particular type of data and nothing else, okay? And we will explore these types in the next couple of minutes, but I would like to warn you that when you put a value in a certain variable that does not coincide with your declared type, then the compiler will raise an error. So violating rules means a syntax error, and this proves that Java is really strict in terms of assigning data type to a variable, and you'll see it soon. So there are 8 data types that are so-called primitive in Java, and primitive types are special data types built into the language. They are not objects created from a class. Okay, let's use an IDE to illustrate everything in here. Hold on. Okay, so here in this source code, we are going to explore more of the data type here, and let's try to have fun exploring each one of the 8 primitive data types in Java. So let me just comment this one out. So 8 primitive data types, okay, data types in Java. Okay, we will be going to explore this one with the use of variables. Okay, so I'm gonna start writing a variable, and I'm gonna illustrate to you at least two examples of each type. So the first type is actually a byte, and let me just name this variable a lowest. And there's a reason why it's like that, why the naming convention is like that. I'll show you quickly. Okay, this one is a highest. And now we have short. We have b lowest. And we have short b highest. And then we have int c lowest. And we have another int d, I mean, sorry, c highest. Then we have long, another data type, long d lowest. And we have another one, long d highest. We have float e lowest, and another float e highest. And then another data type, we have double f lowest. And then we have another double variable, f highest. We have char u plus 0020. You'll know why it's like that soon. Char u plus 0030. And we have another one, Boolean yes. And we have Boolean no. Okay, so if you can see, actually when you try to remove each second example of each type, you will see that there are only 8 primitive data types in Java. And the reason why I made 2 examples of each type, it's because I'm gonna show you the maximum and the minimum data that these data types can hold, okay? So data that is stored in the memory of the computer should be represented in machine readable language in binary form, which is either 0 or 1 called bit. Okay, so all the data value that all these types should hold need to be in a machine readable language, which is in a binary form. So these bits are actually typical, these bits are typically stringed together, and the length of their strings is the reason why the machine can differentiate the data types based on the strings that these zeros and ones are, stitched together. Okay, variables A, B, C, and D are actually integer type variables. So the data that you can put in here are integer types, but these integers can be differentiated based on the number of data values that it can hold. So I'm going to show you an example. So for a byte data type, so this is a byte data type. I will just comment it out. For a byte data type, I need to put like that. For a byte data type, it can hold 8 bits. Can hold 8 bits in the memory of the computer. Okay, in the memory of the computer. So this is equivalent to when you say 8 bits is equal to 1 byte. Okay, so this is how it's being computed. 1 byte is equivalent to 8 bits. Okay, so let's have an example. Let's put a data value here. We have, this one can range from minus 128 integer with that value and equals to 127. So if you see, these two data values assigned to these two byte type variables have these data values. So if I'm gonna decrease the number, say for example, I'm going to decrease the number to 129, say for example. So now it's getting an error. You can see the error because actually that's the limit of a byte type. That's the lowest number it can hold. So the moment that you go down, you go lower than 128, then that means that it will throw an error. The same thing as when you go higher. If I put 128, it starts to show error. So if I'm gonna put 126, there's no error. So in between the range of negative 128 to 127, it's syntactically correct data value for this particular byte type data. Okay, so now let's proceed to the other example of a primitive data type. So in this case, we have short. So short data type, let's say short, let's write it down, short data type. So for short data type, it can hold, okay, so you see, can hold a string of 16 bits, 8 bit, 16 bits. 16, it can hold 16 bits in the memory of the computer. So if 8 bits is 1 byte, so typically this is 2-byte data. 2-byte data. Right? Okay. So let's put an example. Let's have an example. Let's put a data value that is in a short data type value. Okay. So here, if in order to overcome this limitation for in the lowest data that a byte can hold, we can actually use a short type, and short type can actually, in a short type data, you can input 129 and it's valid. And it's not only that, you can go smaller than that, and that's 32,000 32,768. That's the lowest. And then the highest is 32,767. So again, if you go smaller than this, it will start throwing an error. Like I go down, so that is a syntax error. So it cannot hold a data. A short data type value cannot hold data that is smaller than this this lowest data that it can hold. So it will start an error as it will start raising an error. It will raise an error definitely when you go higher than 32,767. If I put additional 1, so it is a syntax error. So that's it for the short. Let's go for the int type. For the int data type, let's try to define it quickly. For the int data type, it can hold here, it can hold 32 bits. Imagine how much data can this type hold in one variable. Okay, so it can hold 32 bits, which is equivalent to 32 bits, which is equivalent to how much? 4 bytes. 4 bytes data. So it can hold 32 bits, equivalent to or equal to 4 bytes. Let me just quickly write it down. It might confuse other people. So equal to 2 bytes data. This one is equal to 4 bytes data. So let's quickly put a data value here. For the integer, the lowest that we can actually we can actually go, the lowest possible number that we can input here is, okay, negative 214,748,3648. So that's it. So I can just copy and paste this one because 0 is included. So I just deduct 1 from that number. So that is acceptable. So see, so this is actually the lowest that an integer, an int, I would say an int primitive data type can hold. Okay, the lowest and the highest data that it can hold. So again, going lower than these value, going lower than this given data value, then you will have an error during compilation. Okay, so let's have the long data type. So a long data type. So a long data type, let's try to define it. It can hold a string. It can hold 32. And if If int value can hold 32, so long can hold 64 bits, equal to how much? Okay, you can do the math. That is 8 bytes data. Imagine. Let's see. The lowest possible here is actually -9 2. There's a lot of digits here. 2, 3, 3, 7, 20, 3, 6, 8, 5, 4, 7, 7, 5, 8, 0, 8. Okay, so this is the lowest, and the highest is the same value. Okay, I'll just deduct 1, and that's it. Wait, there's a red one here. What do you think here? Oh, what do you think happened here? Okay, so actually, all the variables a, those integer type are actually integer literals. Okay, so the moment that you exceed to the integer literal value, which we are going to explore in the next video about literals, those are that is another concept that will be covered soon. Here, as I have mentioned, it cannot actually, the long cannot, if it's already surpassing more than, because it says here type int is out of range. So everything, the integer type, all the numbers are actually an integer type. So it means that the moment that it exceeds more than 9 digits, it will throw an error. So your way to not to override, but your way to escape to this one is to put a literal L, so that you tell the compiler that these are literals. Again, going higher than this will raise an error. Going lower than this will raise an error. Okay, so that's the data type for the integers. So let's try to proceed to the next one, which are data types for real numbers. If you know real numbers, these are numbers that can have um, whole numbers, they can fractions, and they can have decimal point numbers. Okay, so for a float data type, okay, float data type, let's define it. It can hold 32 bits. Okay, equal to how much is 32 bits? 4 bytes data. So again, this one will be can hold, this one can be stored in the memory of the computer. So computer can store this 4 bytes data, and it can recognize float as well. So let's put a value for this one. So the lowest that a float can actually reach is this number, -32 point, okay, 398 9231134. Okay, so again, they are raising red marks. So I mean, yeah, they have red dotted lines. So we'll try to fix it later. So here I'll just deduct that one. So So that's the thing. So I think this one is, I wouldn't say that this will be the lowest, because there could be other lowest number there. I'll just quickly fix the red one. So you put F, literals. Because if I'm gonna put 5 here, if you see, it still work. It's still working. Okay, so it's not really the lowest, but we'll try to rename this one. Instead of saying lowest, probably we can say E small. Okay, E high. So it's not the highest though, but it is something that is higher than the other one. Okay, so because actually float and double, there could be like infinite number of digits, but this one can be like rounded off to 7 significant digits. But yeah, you can actually move beyond that, but actually compilers will be going to round it off to 7 significant digits. Okay, so this one here, 1, 2, 3, 4, 5, 6, 7 will be just rounded to this one. And the compiler, when the compiler compile the your code. So another one for sorry. So we're done with the float. Let's do with the double. So anything that the small, I mean, sorry, the float cannot handle, like smaller than -32, it can be handled by the double. Okay. So for the double data type, okay, double data type, sorry, double data type, it can hold a string, it can hold 64 bits equal to 8 bytes. So it's almost the same as the long, but it just so happened that it is it's holding a real number. So now I will not write F lowest. I will change the variable name to a different one. So F small, and then the other one is F high. Okay. So F small, let's try to initialize this one. Let's try to put data there. I'd like to write data that's smaller than this one. So like that. I don't need to write other letters, because these are literals. The letters that you can see are literals, and again, I will be covering that concept later on in the next video. And then here we have like that. Okay, so these are the doubles. So we usually use doubles rather than float. And if it's an integer type, we use long or int. But yeah, to be safe, I think you should be using um, um, if the value is really high, so of course long, but if it can be handled by int, then go for int rather than short and byte. And when it comes to real numbers, I would suggest always use double, because your digits might not be supported, like the value of pi. The value of pi needs to be double rather than float. So I mean, even if it's 3.14, it can be actually represented by a float as well. But I would suggest that you get used to using double rather than float. Okay, so let's talk about char. Okay, for a char data type, let's see, let's try to define this one too. Char data type. So for the char data type, it can hold 16 bits. It can hold 16 bits equal to how many? 2 bytes. So 2 bytes of data in the memory of the computer, okay? Char can only hold one Unicode character, okay? Char can only hold one Unicode. So when you say Unicode character, these are actually characters coming from different languages. They have the aim to actually collect all the languages, living languages here on Earth, used by humans. And yes, they are being represented to char. So like emojis are actually a char character, I mean data type. So you can, but in this case, I actually input u plus 0020. U plus 0020 actually is, it's actually just a space. Okay, a space character. A space character is actually a Unicode character, U plus 0020. Actually, it's a symbol, there's a symbol plus there, but I just explicitly write plus because it would be a syntax error if I will write the symbol plus in between U and the 4 digits that followed. Okay, so yeah, U plus is actually the space character, and U plus 0030 is actually the initialize it to 0. Okay, so that's 0 is actually equivalent to a Unicode character with a U plus 0030. Okay, so there are so many Unicode characters. I think there are thousands of them. It's not just I think, but I know that there are thousands of them because it's actually around the world. Okay, so that's for Java. But wait, before we proceed to the Boolean, in Java, you need to enclose the value in a single quote to be determined as char type by the compiler. So if you put quotations like that, for example, like that, and then space, that's a syntax error, okay? Because this quotation, double quotation, actually signals that there is a string here, not a char type. Okay, so string will be another discussion. So you will see in the next video, in my next class, you will see you will learn strings, but this time a chart data type needs to be enclosed by a single quote. Okay, I hope that is clear. And then we'll try to proceed to the next one. So Boolean. So Boolean data type, of course, I think you've heard this one from other people as well. It can hold 1 bit. Can hold 1 bit, which is either 0 or 1. So some says, sorry. So some says that true is equal to 1 while 0 is equals to false. Okay, so it's not the same as the other data type that we've just learned earlier, that they have really the equivalent values. But here, a Boolean actually, for example, yes is equals to true, no is equals to false. So zeros and 1 there were not really precisely defined. That is based on Oracle documentation of Boolean data type, okay? So let me repeat myself. According to the Oracle documentation of Boolean data type, The size, which is 0 or 1, isn't something that's precisely defined in Java. Okay, so in other programming languages, they are really explicitly defined. They have like yes is equivalent to 1. I'm sorry, false is equivalent to 0, true is equivalent to 1. But in Java, they are not explicitly, precisely defined the size. It's either zeros or 1. Okay, it's either 0 or 1. So we don't know if true here represents 1 and false here represents 0. But yes, a Boolean can be true or can be false. So if it's true, then of course it's true. But if it's a false, it means that it's not true. So it's something like that. So that's why maybe that's the reason why they didn't really precisely define what Boolean true and what Boolean false data value exactly. Yeah, what exactly the data value is for these two yes, true or false conditions. Okay, let's go to the fun part, the Q&A portion of this video. Okay, the Q&A portion. Let's try to have the Q&A. I will try to ask. This is the Q&A. Q&A part. Okay, so this is the question. Question. In an integer primitive type, if you have listened earlier, in an integer primitive data type, can you assign long? Can you assign long as a short value? Okay, that's the question. Let's see if you can answer this question. I try to pause the video for a while, try to think, and then play the video after a minute, probably. Okay, I hope you get it right. Okay, so the answer actually is no other than yes. The answer is yes. For integer type, all bytes, shorts, int can be of long type, but not all long types are those 3 types. So let me just quickly write it down. So for example, if it's a data type of long, let's try to copy the short, okay? So B lowest. Let's see if this one can be represented. Okay, so here we have an error, duplicate. So I'm gonna write this one is short data type. Okay, DT means short data type. So if you can see, it is not showing an error. So therefore, even though this value is the lowest data that the short data type can handle, but still long can handle it because it's part of its range. Okay, it's part of its range. So the same goes with the float and the double. Okay, so try to take note of that one. Okay, so all doubles contain all the floats, but not all doubles are floats. So this one here, E small, the one that I just explicitly wrote for you, it's actually also a double. Okay, so this float here, which is it can be one of the highest floats you can ever have. So you can actually this one is also part of the double as well. Okay, so that's it. If you think that this video is helpful enough, don't forget to click like, and I'll see you again in my next video. Thank you for watching. Bye.